Hello, I am Hilul Gogoi from Mechanical Engineering, roll number MAB 18007, TEZPUR University. Here this video is for Sessional Test 2, Fluid Mechanics 1, course code ME202, course instructor Prakmani Kolita. The first problem is, for a flow in the xy plane, the x component of velocity is given by u equal to ax y minus b, where a equal to 1 feet to the power minus 1, the second to the power minus 1, b equal to 6 feet, and x and y are measured in feet. Find a possible y component for a steady incompressible flow. It is also valid for unsteady incompressible flow. Why? How many y components are possible? We have to find y component of velocity for a steady incompressible flow. Uh, for that, we know the formula of incompressible flow, that is del of del x u plus del of del y v equal to 0. Here u is the x component of velocity and v is y component of velocity. To find, we have to find v, that is y component of velocity. To find that, we have to integrate this equation. Now here also given u equal to ax y minus b, where a equal to 1 and b equal to 6. Now solving this equation, we will get d of the del of del y b equal to minus del of del x u equal to minus a y minus b. That is differentiating this equation. Now to find b, integrating both sides with respect to y, we will get bx comma y equal to minus a y square divided by 2 minus by plus f of x. Here f of x is a function of x. Now this equation is valid for steady and unsteady flow, because we know that in steady flow the property of fluid particle is independent of time. That is, the property does not change with respect to time. But in unsteady flow, property of fluid particle is depend on time. But since in this question time is not stated clearly, that is, time is not given clearly, so this equation will be valid for both steady and unsteady flow. Now since f of x can be any function of x, that is, f of x can be any value, so there are infinite number of solutions of velocity in y direction. Now if f of x equal to 0, bxy equal to 6y minus y square divided by 2, this is the simplest equation of velocity in y direction. Now coming to the second question, consider the velocity field v equal to a x to the power 4 minus 6 x square y square plus y to the power 4 I cap. This is x component of velocity, and this is y component of velocity, which is equal to a 4x y cube minus 4x cube y, and it is in xy plane, where a equal to 0.25 meter to the power minus 3 into second to the power minus 1, and the coordinates are measured in meter. Is this a possible incompressible flow field? To find possibility of incompressible flow field, we know the formula of incompressible flow field. So from that formula we can check whether this is possible or not. And to calculate the acceleration of a fluid particle at point x comma y equal to 2 comma 1, and we also have to calculate acceleration of the fluid particle. We know the formula of acceleration. So now solution. This is the x component of velocity and this is the y component of velocity, and this is the equation of incompressible flow. Now putting the values del of del x, that is u value, in here, we will get a 4x cube minus 12xy square, and putting the value of b, we will get minus a 4x cube minus 12xy square. Now combine these two, that is putting these two value in this equation, we will get plus minus 0, that is both will be cancelled, it will equal to 0. That means this velocity field is a incompressible flow field. Now we have to find acceleration. To find acceleration in x direction, we know the formula u, del of del x u plus v del of del y u. Here z component is 0. Ax equal to, now putting the value of u and v, we will get ax equal to 4a square x square plus y square all to the power 3. Now for y component of acceleration, we know the formula u equal to del of del x b plus v del of del y b. Here v is the y component of velocity, and here u is the y component of, or x component of velocity. Now so putting the value of u and v, we will get, and differentiating, we will get ay, that is y component of acceleration, is equal to 4a square y x square plus y square whole cube. Now putting the value of a, y and x at 2, 1, that is x equal to 2 and y equal to 1. So then we will get acceleration in the x direction will be equal to 4 into 1 by 4, that is a equal to 0.25, which is equal to 1 by 4 whole square plus 2 x is equal to 2 and 2 meter square plus 1 meter square, that is x square plus y square whole cube. And by calculating this, we will get ax equal to 62.5 meter per second square, and ay equal to 4 into 1 by 4, again ay that is y component of acceleration, 4 into 1 by 4 that is equal to a 0.25, 1 by 4 square into 1, that is y, 2 square plus 1 square, that is x square plus y square whole cube. And calculating this, we will get ay equal to 31.3 meter per second square. Now the resultant acceleration will be root over ax square plus ay square, which will be equal to a equal to 69.9 meter per second square. This is the solution of question number 2. Now coming to question number 3, we are given an incompressible liquid with negligible viscosity flow steadily through a horizontal pipe. The pipe diameter linearly varies from 4 inch to 1 inch over a length of 6 feet. Develop an expression for the acceleration of a fluid particle along the pipe central line. Plot the central line velocity and acceleration versus position along the pipe if the inlet central line velocity is 3 feet per second. Here the inlet central line velocity, that is in the beginning when liquid is entering in the pipe, the velocity is 3 feet per second. 3 feet per second. The pipe diameter 3 feet per second, and here we have to find an expression for acceleration along the pipe central line. To find that, we have to find first velocity, expression for velocity along the pipe central line. For that, we can use continuity equation. According to a continuity equation, we know that the flow rate of liquid through the pipeline is equal in everywhere. That is A1 V1 equal to A2 V2. Now, taking a diameter D in distance x, from inlet, we will get the value of d equal to di plus d naught minus di divided by L into x. That is the total length. L is the total length. X is the distance from inlet to a diameter d, and the d naught is the exit velocity or exit diameter, and the I is the inlet diameter. And also take vi and ai is the inlet velocity and inlet area, and vo is the vo is the velocity at the exit. Now we know the formula of area, A equal to pi d square by 4. Now again, putting the values from the continuity equation, we will get taking consideration of inlet in n of a diameter d. We will get vi pi d vi ai equal to va. Here a is equal to pi d square by 4, and d is equal to di plus d naught di L by L into x, and vi at inlet area will be equal to pi di square divided by 4. Now solving this equation, we will get vx equal to vi 1 plus d naught di minus 1 divided by L into x whole square. Now that is velocity will vary with respect to x. That is, depending upon the value of x, velocity will be changing. Since we know the vi, we know the d naught and di. Here d naught by di equal to 1 by 4, and vi equal to 3 given in the question. L equal to 6, and x can be 1 to 6 or 0 to 6. So now putting the values, we will get some values of v at 0, that is given 3 feet per second, and v L by 2 that is 3 in 3 feet 6, it will equal to 7.68 feet per second. Velocity equal to 7.68 per feet per second. Putting all the value of d or di and vi L etc, and at L, that is L equal to 6, that is x equal to 6, when x will be equal to 6, that is VL, it will equal to 48 feet per second, and when x equal to 3, this velocity will be equal to 7.68 feet per second. Now we have to find acceleration. Here, since the acceleration is given only in x direction, so we can find from the formula, that is ax equal to v del of del x v. From this equation, and solving this, we will get that is putting the value of v. Here v value is this one, and again del of del x v, and this and deriving and multiplying both, we will get this equation, and this will vary with respect to x. That is, depending upon the value of x, acceleration also vary. Now putting some values, now take some value of ax, which with respect to x, that is in geometer, in when 0 feet, I mean this meter is feet, when acceleration is at 0, x equal to 0, it will equal to 2.25. Ax will be equal to 0, and putting the all the value, we know the all the values vi, d naught by di, and l. Putting those value, we get 2.25 feet per second square, and Ax equal to L by 2. L by 2, that is 3. Putting the x value equal to 3, we will get 23.6 feet per second square. And again, putting the value x equal to L, that is 6, we will get the value as 2.30 into 10 to the power 3 feet per second square. We can see here, we can plot the velocity. We can plot the graph, that is velocity and displacement graph, and acceleration and displacement graph. From the values, we can easily draw the graph. That is, we can see the velocity will increase which when area is decreasing. That is, when displacement is going, more displacement with respect to displacement, velocity will increase due to continuity equation. And also in acceleration, you can see it's mostly equal, and at the end point, that is at the exit, acceleration vastly increase. Thank you.